Hello, I'm Ketan Goel. Today I'm going to tell you about classification of steel sections. So first we will see what is steel. So what is steel? Steel is basically a compound which is made up of iron, small amount of carbon in it by weight to give it strength, and then some materials like sulfur, phosphorus, manganese, chromium, silicon, and nickel, which make it corrosion resistant. So these, except carbon, the rest of the materials are used to make it corrosion resistance, and carbon to give it strength. Then we'll see the advantages of structural steel over normal RCC concrete. As we all know, steel has very high strength. Again, we are adding carbon in it, so it will provide more strength to it. It will give you high strength within very lesser area, so the dimension of the section can be reduced. As we see in concrete, we have more depth of beam, like it will go to 1 meter to sometimes 1.5 meter to 2 meters. But if we use steel section instead of RCC beams, then we can provide more strength within very lesser area, very lesser dimensions. Again, it will provide you economical sections. Yeah, economical section due to high strength to weight ratio. And as the depth of the sections decreases, it will provide you more of the clear span. Then construction can be done rapidly as the already made sections are available, and we just need to procure it to the site and just install it. So the construction can be done within very short time. As we see for RCC, we need to first put the reinforcement, then cast it, then cure it for provided time, like 7 days or 28 days, whatever is required. And then again putting the scaffoldings, shutterings, again removing it. So all this time can be saved if you go for the steel structures. So construction can be done very rapidly if you go for steel structures. Then steel has more ductility. Steel has 100% scrap value. So after using it for the construction, again if you want to reuse it, you can reuse it. And if it is waste, broken, whatever, then again still we can sell it. So it is having 100% scrap value. So whatever your investment, you will get the returns. Repairs and modifications are very easy, as just simple connections are there. We can remove it, again uh, replace it or reuse it somewhere else. The whole structure we can move it, again stand it some other side. So repairs and modifications are very easy if you go for steel structures. Then high quality and reliability, as steel has more strength, so again it is more reliable. And as I said, the construction cost is very less. Now we'll see the disadvantage. Steel has only one disadvantage, but it is a severe one. So structural steel is susceptible to corrosion, and it is very less fire resistance. So if steel structure is subjected to high temperatures, it can melt. Some members, weaker members can fail also. So in that case, this is the disadvantage of using structural steel. Okay. So moving to classifications. First, we'll see the general classification. So in general classification, we have reinforcing steel and structural steel. Reinforcing steel is one that we use as a reinforcement in any of the RCC buildings. The bars that we use of different diameters, that comes under reinforcing steel. So it is designated as FE 250, FE 415, then FE 500. These are the general grades that we use for the bars in RCC structures. Then coming to structural steel. Second classification is structural steel. So structural steel sections are used in steel buildings. Whatever steel buildings we see as bridges, then again trusses over railway stations, and some steel bridges, then again industrial buildings. So that generally we designate it as FE 415 and FE 540, the higher grades. We'll go for higher grades. And second classification is based on carbon content. So carbon content provides the carbon, as we increase the carbon content, the toughness will increase, the strength will increase, but the ductility will decrease. Okay, so ultimate yield and ultimate tensile strength and hardness of the steel increases, and ductility and toughness decreases when more amount of carbon is added to iron. So first we'll see, the first one in this is low carbon steel. So in that, the percentage of steel is in between 0.1% to 0.25%. That is low carbon steel. Low carbon steel, we can say mild steel. Mild steel is low carbon steel, and it can be used in RCC structures as reinforcement or general steel structures also. Then second classification is medium carbon steel. In that we have 0.25 to 0.60 percentage of carbon. If that percentage of carbon is there, then it comes under medium carbon steel. So this medium carbon steel we can used as rails, the rails on which train moves. Then again tires, the vehicle tires over which we have that rubber tube and all. So tires can be prepared from this medium carbon steel. Next we have high carbon steel. So high carbon steel contains the carbon percentage of 0.6 to 1.1%. That will come under high carbon steel. And high carbon steel will have more stiffness, less ductility, more hardness, less toughness. So it can be used for hammer, stone, masonry tools, and drills and punches for drilling equipments. And as I said, we need to note that as carbon content in steel increases, the toughness and ductility will decrease, but the hardness, yield, and ultimate tensile strength will increase. Next classification is based on the availability of the section. Whatever sections are available there in the market from Indian roll mills, based on that we have this classification, like rolled steel I sections, rolled steel channel sections, then rolled steel I sections, rolled steel bars, and then rolled steel plates, rolled steel sheets, rolled steel flats. So this classification is according to the availability, whatever the sections are there available in the market, according to that, based on that. So first one is I section. So in I section we have this 5 different I sections. First one is ISJB, that is known as Indian Standard Junior Beams. This JB, LB, MB, WB, and HB are the designations. This is the identity of that section. So first one is ISJB, Indian Standard Junior Beam. Second one is ISLB, which is Indian Standard Light Beams. Then MB, which is medium weight beams. Then WB, that is wide flange beams. And then HB, that is heavy weight beams. So these 5 comes under I sections. So ISMB generally we use for floor beams as floor construction. Floor beams we use as ISMB. Then this ISWB, wide flange beams, these have more moment of inertia about principal axis. Again, ISWB supports is used to support transverse as well as lateral loads. Then ISHB we use for same depth but more area and more radius of gyration. It will provide more area and more radius of gyration. It has thicker web and thicker flanges. That is why it is heavy weight beams. We need to note that I section for same weight, out of available sections, I section will provide more moment of inertia or section modulus about its minor principal axis. Hence, I section is most economical or efficient section for beam or girder amongst all the available sections. Again, to support heavy transverse loads which are parallel. Transverse loads are those which are parallel to your minor principal axis. So to support heavy transverse loads, it will provide you more moment of inertia about, we required more moment of inertia about ZZ axis, that is major principal axis. To support lateral loads, with the loads which are coincident with major principal axis are called lateral loads. So in that, for supporting lateral loads, we required more moment of inertia of this or section modulus about YY axis, which is minor principal axis. As I said, for same height, ISWB section will provide you more moment of inertia about its minor principal axis as compared with its counterparts. Hence, ISWB section will have more lateral bending strength, as it will give you more moment of inertia about minor principal axis that is required to support lateral loads. Then coming to channel sections, next we have channel sections. So in channel sections we have ISJC, that is junior channels, then ISLC, that is Indian Standard Lightweight channels, ISMC, that is medium weight channel with sloping flanges, and next one is ISMPC, that is medium weight channel with parallel flanges. So these are the C sections available. So ISLC section, lightweight section, we use in general steel constructions. Then we have, next one we have angle sections. In angle sections we have equal angle section, which are designated as ISEA or generally ISA. It will have both the legs equal, of equal length, of equal dimension. That will be equal angle section. And unequal angle section will have one leg of more length, more dimension, and other leg shorter. One shorter leg, one longer leg will come under unequal angle. That is designated as ISA. Then again we have bulb angle in that. So it will have bulb at its end. So those section will come under bulb angles, and that is designated as ISBA. And this bulb sections we generally use for ship constructions. Then next we have bars, Indian Standard bars. So in bar we have two categories, that is Indian Standard round bars and square bars, that is based on the shape. So round bar we designate it as ISRO, and then square bars we have that we designate it as ISSO, that represent square and that R represent round. These two types we have in bars. Then coming to next classification, that is plates. After bars we have plates. So if we need thickness less than, T represent thickness, so when we require thickness less than or equal to 5 mm, then we'll go for plates. So these plates are designated as ISPL. Then we have sheets. So if we require thickness less than 5 mm, then we will go for sheets. It will have very less strength, so that is obviously required for carrying lesser loads, and that is designated as ISSH, which represent sheets. So these sheets will have lesser strength than plates. And then we have flats. So when we require thickness greater than or equal to 50 mm, then we will go for flats. Then we will select flat sections, and that is designated as ISF. So F represent flat. Obviously, as compared to plates and sheets, it will have more strength, and that we will use for to carry more loads. So this is overall classification according to the availability of the section in the market from the Indian rolled steel. Then we need to note that according to based on all the analyses from all the available sections, only I section will give you, I section are the best sections for carrying more loads, and then regarding according to the dimension and strength, and the based on the loads that we need to carry, we'll select the section. Thank you.